In this video, we're going to talk about using fraction models to add fractions together. The first thing we need to figure out is what is fraction models and how do they work. There's a bunch of different types of fraction models. We're going to look at one type right now. We're going to look at pattern blocks as fraction models. So here we have a yellow hexagon shape. We're going to call this one whole thing, the yellow hexagon. We also can have a red trapezoid. And as you can see, that is half of the entire yellow hexagon. So this would be 1/2. And we can tell that because if we use two of them together, we end up with one whole. The next thing we're going to use is our blue rhombus. This represents 1/3. If I put three of these together, then I can create one whole shape. And the last pattern block that we're going to use today is the green triangle. I need 6 green triangles to make one whole, so that means that each of these is worth 1/6. I'll put them together now. So these are the 4 types of pattern blocks that we're going to use. Whole, 1/2, 1/3, and 1/6. We can use these pattern blocks to help us to add fractions of different denominators. Whenever you're adding fractions with models, notice that the final answer has to have all pieces in the same denominator. Otherwise, it won't work. Our first example is 1/3 plus 1/6. So I'm going to put those together and see what happens. Here's my 1/3. And here's my 1/6. When they go together, they look like a different shape that we already have. They look exactly like the half. And in fact, if I put these on top, they would exactly fit the half. So the answer, when I put 1/3 and 1/6 together, is 1/2. The next example that we're going to look at is 1/3 plus 2/6. So I take out my 1/3 again. And this time I take 2/6 pieces and put them together. When I look at this, the 2/6 pieces look a lot like the blue rhombus, the 1/3 piece. So I can actually replace that and I end up with 2/3. So the answer to 1/3 plus 2/6 is 2/3. The last example that we're going to do with pattern blocks is 1/3 plus 3/6. So I take out my 1/3 and I take out my 3/6 and put them together. When I do this, I look at this and I see that 2 of these 6 would make the blue shape, but 3 of them don't work. So what I need to do instead is replace the blue one. So, to do that, I can see that 2 green ones would fit in the spot where the blue one is. And my final answer is 1, 2, 3, 4, 5 6s. Whenever you're doing problems like these, notice that the final answer has to be all of the same color. It has to be all the same type of block in order for it to make sense. We can use pattern blocks to show subtraction as well. Again, this is one whole. This represents 1/2. This represents 1/3. And this represents 1/6. Our first example using pattern blocks for subtraction is 2/3 minus 1/2. So I set up my 2/3. And I want to make sure that they kind of look like the shape of my hexagon. And then I have to minus 1/2. In order to do this, I lay the 1/2 on top of the 2/3. And that makes this part kind of disappear. The part that's left over right here is my answer. So in this case, the pattern block that fits on top of that is this little green one, which, if you remember, is 1/6. So the answer to 2/3 minus 1/2 is 1/6. The next example that we'll do is 1/2 minus 1/6. So just like before, I lay out my red block. And since I'm subtracting 1/6, I put that on top of the red block. This area left over is the answer. And if I look at that, I can see that the 1/3 block will fit in that space. So my answer to 1/2 subtract 1/6 is 1/3. Pattern blocks are a good way to show addition and subtraction of fractions, but unfortunately they're a bit limited because we only have certain pieces, so we can only show certain fractions. The next model we're going to look at is fraction circles, and we have a better chance of making different types of fractions with them. The first example we're going to look at is 2/4 plus 3/8. In the fraction circles, the fourths are yellow. And if I take 4 of them, I make one whole, which is how I can tell that each of these is worth 1/4. So here, I'm asked for 2/4, so I'm only going to use 2 of them for this problem. I'm also asked for 3/8. The 8s are blue, so I'm going to take 3/8. Since I'm adding these, it means that I'm putting these things together to see how much the total will be. So I'm actually going to just combine these together and find out the total. In order for this to work, though, every one of these pieces has to be the same denominator or the same color. I could try replacing with yellow, but there's this piece left over and the yellow won't fit just over that piece. Another option is to replace them all with blue. So that's what I'll do. So when I add 2/4 and 3/8, then I change them all so they have the same denominator, I find that the answer is 1, 2, 3, 4, 5, 6, 7/8. So 2/4 plus 3/8 equals 7/8. My next example is 2/5 plus 5/10. The green ones are fifths, and I'm going to use 2 of those. And I need 5 purple ones to make 5/10. So since I'm adding, again, I have to push them together and see what the final total is. So when I do this, well, now I have to change them so that they're all the same color or the same denominator. I could try green, but when I try green, I find that I have this space that's not filled. So, again, I have to go with the lower denominator. I'm going to replace the greens with purples. Now all I have to do to find the answer is count them. 1, 2, 3, 4, 5, 6, 7, 8, 9 of the purple tiles means 9/10 is the answer. In this example, we're going to do 2/3 plus 1/2. My thirds are orange, and I take 2 of them. Then I have 1/2. Since I'm adding, I have to push these together. But when I do, I see that they don't fit really well together. In fact, there's more stuff here than can fit in one whole thing. So I know that the total is greater than one whole. So it's one and something else. So I have to split this one into pieces in order to figure out what that extra piece is. So I know that this is 1/3, and I can split it into 2/6. So when I do that, one of the 6ths fits well, and one of them is extra. So I know that this is 1 whole and 1/6.